So today we're going to look at the topic oscillation and the subtopic resonance. So resonance occurs when force frequency is equal to its natural frequency, and what happens is they both add up and the resultant amplitude is the summation or the addition of both, and this keeps on happening as long as the condition is met. We will look at the condition later. So this one is the book definition, but I have my own definition, I think, which describes the resonance thing better. But before even coming to that, we have to know what natural frequency is. So natural frequency is the frequency at which let me write it, the frequency at which objects oscillates, or they like to oscillate after an initial disturbance. So for instance, a swing or a spring, like after you you pull it or like disturb it, a few seconds later you will see that it's constantly moving at the same rate, and if you time it and find the frequency, you will keep on getting a constant frequency. And for that same object, if you do it again and again, you'll find that that frequency is same. So what we see is that objects, they tend or like to move at their at a frequency that is unique to them. That's unique for that object. Another example we have is the tuning fork. So it's a metal that's connected to a wood stand. So if you disturb it or provide a force, after a few times you will see that the sound frequency you are getting, it's same, it's constant, and that's the frequency. The frequency that it vibrates, it likes to vibrate. That is the natural frequency. Even a solid object, they have their atoms moving at random. They have their own vibration. So that vibration is also, that is also their natural frequency. So every object has their own liking of vibrations. That frequency is the natural frequency. So moving on, we have resonance. So we have looked at that the book definition is this: that resonance occurs when force frequency is the frequency that you provide, that must be equal to the natural frequency. So what natural frequency was, that, as I said earlier, is that frequency which objects oscillates after an initial disturbance, and the resultant amplitude is they add up. So that's the book definition, but what I describe this as is it's the opposite of damping. So what happened in damping was, if my restoring force, for instance, was this side, my air resistance was this side. So my air resistance was the damping, the force that was resisting it. So the force was opposite, but in resonance the force is on the same direction, and also how I describe is that you get the timing or the frequency right. So what happens is, so that the energy, like if any string or spring is, so the thing is, the condition is that so the condition here is that the force that you are providing, the driving force, that force that you are providing, or the driving force, the driving frequency, must be equal to that of the natural frequency. So if you can somewhat make that equal, so they add up, and what happens is the energy is now twice, and this keeps on adding up, and the resultant frequency keeps on getting bigger and bigger. And even for example, let's look at the breaking of glass. So they have a natural frequency. The glass have, the particles are vibrating at a frequency. So what the the musician, what they do is that they try to match that frequency with their sound. So if they can match it, so this addition thing happens, like the natural frequency, and as they're it keeps on adding and adding, and the resultant frequency gets so big that it breaks. So that's what happens, and that's what resonance is.